Okay, let's jump right into this. Welcome to the boxing ring, where your hard-earned physics knowledge is about to go absolutely toe-to-toe with the Cambridge Examiner's marking scheme. Today, we are tackling the ultimate high-stakes explainer on specific heat capacity. And listen, whether you're taking syllabus 0625, 0651, 0652, 5054, or 9702, this is the exact strategy you need. Now, in the red corner, we have a student we'll call Alex. Alex is brilliant, super hardworking, but honestly, in the exam hall, Alex just throws wild haymakers. You know the type? Alex overloads every single answer with raw physics facts, dumping the entire textbook onto the page, but provides absolutely zero analysis. And then, over in the blue corner, we have Sam. Now, Sam is fast, way too fast actually. Sam throws these rushed, panicked jabs, constantly missing the specific command word requirements of the question entirely. And if you look closely at their papers, their flawed answers are literally bleeding red ink from the examiner's pen. It's tough to see. But hey, by the end of this session, we are going to train you to operate completely differently. We're going to teach you to float like a concept and sting like evidence. We're going to take those red pen marks and transform them into solid, undeniable green check marks.
So, here is the million-dollar question. Why do top students, candidates who know all the physics facts, who spent hours memorizing every single textbook definition, why do they still consistently drop marks on this specific topic? It's genuinely a tragedy, and I see it happen year after year. Let me put this into perspective for you. Specific heat capacity, along with its associated temperature and energy changes, accounts for approximately 15% of your total examination marks. Yeah, you heard that right, 15%. That is massive. That's not just a dropped mark here or there. That is very often the literal difference between two entire grade boundaries. You might know exactly what specific heat capacity is in your head, right? But translating that abstract concept into the precise, rigorous phrasing the Cambridge assessment objectives actually demand, well, that's a completely different skill. The exam isn't just testing your memory. It targets distinct cognitive domains. Sure, it tests knowledge and understanding, but it heavily weights application and analysis. Both Alex and Sam, they know their physics, they really do, but they are failing the strategy game. They're suffering from what we call the illusion of competence. They see a question about, say, an experiment to measure the specific heat capacity of a solid or liquid, and their brain just dumps everything it knows onto the page in a total panic. But as we're going to see today, the examiner is looking for a very, very specific combination of punches.
Now, what's really fascinating about this slide is the revelation directly from the people grading your papers. This is an actual quote from the Cambridge Principal Examiner reports. They state, quote, "Answers are often too vague. Examiners want specific details. Students forget to check format and presentation." Think about that. The biggest trap you face isn't a lack of knowledge. It's a failure to be precise and specific to the given context. This is the exact trap our student Alex falls right into. Alex thinks that writing a massive paragraph of general physics trivia is a guaranteed way to score marks. But here's the reality check. The assessment framework heavily prioritizes analytical depth over superficial breadth. The examiners are explicitly warning us right here on this screen. They don't want a generic, nicely written story about heat. They want targeted, logical, structured reasoning. They want you to identify limitations, state the exact assumptions made in an experiment, and show exactly how alternative interpretations would affect the final conclusions. When a question asks you to evaluate an experiment measuring the specific heat capacity of a liquid, giving a vague answer like, "Oh, just make sure it doesn't lose heat," well, that is exactly what the examiner means by too vague. You get 0 marks for that. You have to specify exactly how, for instance by explicitly stating you'd add an insulating jacket or a lid to the calorimeter. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Let's actually look at what this means in practice. We need to contrast a flawed, generic student answer with the exact, precise terminology required to actually secure those high-level knowledge and understanding marks. Take Alex's classic vague answer here. Heating makes it hotter. Okay, sure, technically that's true in everyday conversational language. But in a Cambridge physics exam, this earns absolutely 0 marks. Now contrast that with the mastery level response right next to it. Temperature increase means increasing internal energy and average kinetic energy. Boom. That is exactly what they want. And this is where we need to apply our core strategy, the Peel framework. Point, evidence, explanation, link. The point here is the temperature increase. The explanation relies entirely on the microscopic model of matter, stating that the average kinetic energy of the particles is increasing, which inherently means the overall internal energy of the system is increasing. Do you see the massive difference there? One is just a casual observation you'd make making tea. The other is a rigorous, structured scientific explanation. Ask yourself honestly, Which one of these do you usually write when you're rushing in an exam? If you want those top grades, you've got to structure your answers like that mastery level example every single time.
Okay, let's get into the math of it. The absolutely crucial point here is mastering this core foundational equation. You know it, I know it. C equals delta E over m times delta theta, where C is the specific heat capacity, delta E is the change in internal energy, m is the mass, and delta theta is the change in temperature. Now listen, this isn't just an equation you blindly memorize. It is a literal tool for deconstructing complex problems. This equation is the exact mathematical definition of specific heat capacity, the energy required per unit mass per unit temperature increase. But here's where it all goes wrong. When our second student, Sam, sees this formula, Sam just rushes. Sam blindly plugs in the numbers without ever checking if the mass given in the question is in kilograms or grams, or checking if the energy is in joules or kilojoules. And that's exactly how you bleed marks. The command words in your exam, words like calculate, determine, or show that, they require you to decode this information methodically. You've got to demonstrate connected, conceptual understanding. When you heat a solid block of aluminum or beaker of liquid water, this specific equation dictates exactly how much thermal energy is being transferred into the internal kinetic energy of those microscopic molecules.
And this brings us to a brilliantly powerful framework that examiners practically beg students to use: deconstruct, solve, evaluate. This is exactly how top-scoring elite candidates think. Let's break it down. Step 1. Deconstruct the given information. This means you read the question carefully and actively extract the relevant data. You literally ask yourself, what is the mass? What is the initial temperature? What is the final temperature? Step 2. Solve systematically. You don't just mash numbers in a calculator. Break the calculation into logical, visible steps. Write down the formula first, then physically write down the substituted values, and only then calculate the answer. Step 3. Evaluate results and check for reasonableness. This is huge. This is where you pause, take a breath, and look at your final answer. If you calculate the specific heat capacity of a solid piece of metal and you get, 3 million joules per kilogram degree Celsius, your evaluate alarm should be screaming at you. Does that number make physical sense for a piece of metal? Absolutely not. You almost certainly forgot to convert a unit, like kilojoules to joules. By applying this 3-step framework, you instantly stop being like Sam, who rushes and makes silly, easily avoidable errors, and you start operating like a top-tier candidate who actively verifies their own reasoning at every single stage of the process.
Let's move on and see how this builds into a fully standardized sequence that prevents you from rushing and missing those critical command word requirements. Think of this as your physics success blueprint. This is how we turn those red pen marks into beautiful green check marks. First up, identify key elements by physically highlighting the physical quantities given in the text. Get your pen out and circle them. Second, apply relevant principles. Ask yourself, are we dealing with an increase in average kinetic energy here? Are we looking at a system reaching thermal equilibrium? Third, execute analysis with clear working. We're going to talk a lot more about this in a second, but I promise you, this is your ultimate safety net. Fourth, verify results by constantly checking for reasonableness, like we just talked about. And finally, present an appropriate format. This means using proper headings, the correct terminology, the appropriate units, and clear annotation. Look, if the command word says state and explain, you absolutely must do both. If you only state the fact, you instantly lose half the marks. It's that simple. This systematic processing develops professional, high-level academic skills and ensures your analytical depth completely overshadows any superficial breadth. This list right here is essentially your ultimate survival guide for the exam hall. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, welcome to the interactive workshop part of our session. I want you to look at this data interpretation challenge for measuring the specific heat capacity of solids and liquids. You've got about 60 seconds in your head to scan this. Your goal is to extract relationships and draw evidence-based conclusions. What happens when the energy input is totally identical for the solid and the liquid, but their specific heat capacities differ? Did you spot the core trend? The substance with a higher specific heat capacity, let's say the liquid water here compared to the solid metal block, will show a much smaller temperature change for the exact same energy input. Why is that? Well, because water requires significantly more energy to increase the average kinetic energy of its molecules. Extracting these specific relationships from texts and tables is an absolutely non-negotiable skill if you want top marks. Examiners love, and I mean love, giving you mock experimental data just like this and asking you to spot the anomalies or explain the trends using the exact specific heat capacity definition.
Okay, on to challenge number 2. Find the flaw. Look at this slide. This might actually shock you, but an examiner alert reveals that even if your final calculation is completely 100% wrong, you can still secure almost full marks. Look at that, 3 out of 4 marks for a totally wrong answer. How on earth is this possible? It's all because of the process. You see, Cambridge physics isn't just about the final number at the bottom of the page. It's about the logic, the structured reasoning, and the methodology you use to actually get there. If you write down the correct equation, and you substitute the correct initial values, but you make a silly calculator error at the very last second because you're stressed, the examiner still rewards your physics understanding. You successfully demonstrated knowledge, application, and analysis, even if your basic arithmetic completely failed you under pressure.
And this brings us to the vital method mark strategy. Listen carefully, because students who lose marks often just fail to show they're working. So always document your process to save your grade. Let's break down exactly how to guarantee these safety net marks. First, show while working clearly. Never ever do calculations purely in your head or on a scrap piece of paper that you're just going to throw away. The examiner can't mark what they can't see. Second, break it into logical steps. If you need to calculate the energy from a power rating in a time period first, before you even plug it into the specific heat capacity equation, physically show that intermediate step on the paper. Third, apply correct formats. Fourth, use appropriate terminology. Please don't write something casual like, the heat went into the block. You need to say thermal energy was transferred to the internal energy of the solid. That's the terminology they want. Fifth, include clear annotation. State exactly what each number represents. Think about Sam from earlier. If Sam had used this method mark strategy, Sam wouldn't have lost 4 out of 4 marks just because of a rushed unit conversion error. Sam would have walked away with 3 marks. And believe me, over the course of an entire exam paper, those method marks easily add up to a full grade boundary jump.
Let's move to Challenge 3, speed writing. We're looking at superficial breadth, which is just listing facts, versus analytical depth, which means identifying limitations, assumptions, and alternative interpretations. Top-scoring candidates demonstrate evaluative thinking by moving away from those superficial facts and instead actively questioning assumptions and justifying their decisions with real evidence. Consider a superficial student answer. To measure the specific heat capacity of a solid, use a heater, a thermometer, and measure the temperature. I mean, sure, that lists facts, but it completely lacks analytical depth. Now contrast that with the mastery-level version. To accurately measure specific heat capacity, the solid must be wrapped in insulation to minimize thermal energy dissipation to the surroundings. An assumption is made that all energy from the heater transfers to the solid, which is a limitation of this experiment. Wow. Do you see the absolute power of that second answer? It proactively identifies limitations. It clearly names the assumptions made. It considers the actual effect on the final conclusion. This is the exact evaluative level that the higher-order assessment objectives demand. Take the classic exam question about putting oil in the thermometer hole of a metal block. A superficial, rushed answer just says to read the temperature. But an analytical, top-tier answer says to ensure good thermal contact, allowing accurate measurement of the internal average kinetic energy. It's night and day, folks.
We are in the final stretch now. Remember this number, 15. Applying this procedural framework directly to specific heat capacity and its related energy changes represents a massive 15% of your total examination marks. You now possess the complete, ultimate physics answering system. It really all boils down to 3 core rules that absolutely guarantee top marks. Rule number 1, command word decoding. If the question asks you to describe, do not give an evaluate answer. Give the examiners exactly what they are asking for. Rule number 2, the Peel framework application. Make your point, back it up with concrete evidence from the provided data table, explain the physics using precise terms like internal energy and kinetic energy, and then link it all back to the original question. And rule number 3, the time management matrix. Don't rush blindly like Sam, but also don't overwrite a novel like Alex. Use the deconstruct, solve, evaluate method we went over to pace yourself perfectly through the entire exam. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
So I'll leave you with this one final thought. As you head into your next past paper practice session, ask yourself honestly, are you just memorizing disconnected facts, or are you truly mastering the examiner's analytical framework? Because let me tell you, the difference between rote memory and deep evaluative understanding is literally everything when it comes to Cambridge exams. So the next time you look at a simple block of heated metal in a practice question, ask yourself, are you seeing just a basic temperature change? Or are you finally seeing the hidden energy dynamics that dictate the physical world, perfectly decoded for the examiner? Keep practicing, keep evaluating, and you'll nail this.